Once again, good morning and welcome to our general mathematics class. As I mentioned earlier, we are now in the start of lesson 3 and we'll tackle 10 lessons for this chapter. Lesson 3.1 talks about inverse functions. And for you to perform well in this lesson, you need to go back to our first lesson in chapter 1, the introduction on functions for us, and we will have a very brief review this time. Let's first recite today's memory verse, and it's found in Jeremiah 7 verse 24. It says, "But they hearkened not, nor inclined their ear, but walked in the counsels and the imagination of their evil hearts, and went backward and not forward." Today's MVCA Boosters is about one-to-one in love stories. For our love relationship to be functional, it must be one-to-one, not only function, but it must be a one-to-one function. That is one man to one woman. You need to share with us 3 couples in the Bible with one-to-one relationship. And then you need to read Genesis 29 and answer this question. Why was the story of Jacob's family full of conflicts? Let me give you a hint. Before in your MVCA Boosters in chapter 1, lesson 1, I asked you to write 3 couples with a functional relationship. It must be a function. Remember, in a function, the X does not repeat. Some of you there wrote Jacob. And you see, I didn't give you a full credit of 5 points. Instead, for every wrong pair, that's -1. Why is Jacob and Rachel a function? Because there's also another pair, like Jacob and Leah. So it's not a function. Some of you wrote there Abraham and Sarah. But I'm so sorry, I also marked that one because even if it's unofficial, there's also Abraham and Hagar. So it's not a functional couple. Also, some of you wrote Elkanah and Hannah. Still not a correct one, because Elkanah and Hannah, we also have Elkanah and Penina. So again, the X does not repeat. But in your MVCA Boosters, it should be one-to-one. No extras. One man, one woman. So try thinking about that. No other extras, okay? No other husbands, no other wives, no concubines. Now, at the end of today's lesson, you'll be able to represent real-life situations using one-to-one functions, determine the inverse, and then represent the inverse of the function through its table of values and graph, find the domain and range, and solve problems involving inverse functions. It'll be a long topic today, so let's start. Now, here's our venture activity, and here's how I illustrate inverse functions. Like, for example, there's the chick, then it goes up process, it becomes chicken nuggets, but the inverse also works like this. From chicken nuggets, you place in a machine, the ending will be original, the chick. Or another, if I'll place apples in a box and it will result to lemons, that's X to F of X. In the inverse function, if I'll place the lemons again, it will result to my original, the apples. So that's how I'll illustrate inverse functions. One is the inverse of another. Now, let's start by talking about one-to-one functions. Like, what is a one-to-one function? Remember, we first described a function. And in chapter 1, lesson 1, we talked that a function is an ordered pair, a set of ordered pairs where the x does not repeat. Example, 1a, 2b, 3c, 4d. If you'll check the x's, the x coordinates, 1, 2, 3, 4. It does not repeat. Therefore, it is a function. But for it to become a one-to-one function, the y should also be unique. So after checking your x's, you need to check your y's. A, B, C, D. It does not repeat. Therefore, it is a one-to-one function. Another, 1a, 2a, 3a. Let's check first if it's a function. Let's go with the x's. 1, 2, 3. The x does not repeat. Therefore, it is a function. But as you'll check your y's, A, and A, your y is repeating. Therefore, it is a function, but it is not a one-to-one function. Other samples, 1 and A, 2 and B. Here, if 1 is paired with 2 and A is paired with 2, it's a function. The x does not repeat, but it's not one-to-one because 2 is being paired to 1 and A. But if 1 is paired with 2 and A is paired with B and without this one, then it becomes a function and it is one-to-one. Now, what are some examples of one-to-one function? Example, in real life, there are so many one-to-one functions. Like, for example, think of your parents' relationship. It should be one-to-one, right? For it to be functional. Or else, if it's not one-to-one, there might be some conflicts. Now, here are some examples in real life of a one-to-one function. Like, each person has a different DNA. Or what a passport number for each passport holder. It will never be the same. Or your student account code. Even if you are siblings, it's different for each student. Like, for example, even if you have the same name, like in my name, S. Pon Lee, but mine will be 001. The next person to me with the same code will be 002. So it's never the same. Next, for cars, one plate number for each registered vehicle. One toothbrush for each person. It should not be 1:2, okay? And one man, one woman relationship. Now, if the function is a graph, we use the vertical line test, right? So for example, if this is our sample graph, we draw the vertical line test to determine if it's a function. So draw, oops, once only. So it's a function. But to determine further if it's a one-to-one function, we need to do the horizontal line test. You draw the horizontal line, and if it will only cross the graph once, then it is a one-to-one function. But remember, before you do the horizontal line test, you need to do the vertical line test first. Why? Because the vertical line test will check, is it a function? And then the horizontal line test will check, is it a specific type? a one-to-one function. Example, if I'll have this one, if I'll draw a vertical line test, it will cross twice. So it's not a function. So no need to check. Ma'am, if I'll draw a horizontal line test, it only crosses once. Yes. However, it's not a function. It looks like this one. If you want to see if it's a Carabao mango, you need to check first. Is this a mango? Before you say, is this a Carabao mango? For example, oh, it looks like a Carabao mango, but it's not a mango. It's an apple or it's a guava. So what's the point? You need to check first if it's a function before you check if it's a one-to-one function. Another example, this graph. Crosses once by horizontal, by vertical. Yes, it's a function. By horizontal, yes, it's a one-to-one function. Here are more examples. The first one, not a function. No need to check if it's one-to-one. The second one, it's a function. But if we check horizontally, passes by many. So it's not one-to-one. The third, it's a function by the vertical line test, but with the horizontal line test, it crosses twice. So it's not a one-to-one function. The third one, vertical line test, once. Horizontal line test, once. Therefore, the last one is a one-to-one functions graph. Any questions?
None, ma'am.
Thank you for that. If you don't have any other questions, let me proceed to the next subtopic. The next subtopic is about inverse. Now, what is the inverse of the function? Here, let me give you an example. 1a, 2b, 3c. This is my original function. If I'll say inverse of the function, I will simply exchange the x and my y. So from 1a, its inverse will be a1. From 2b, its inverse, that's f to the -1, it means inverse is b2. For 3c, its inverse is c3. So you see, if you say inverses, we just switch the order of our x and y coordinates. If your main function is f of x, we write the inverse as f of -1 of x. Now, we'll check on some properties. If the inverse is a one-to-one function, then the function is also one-to-one. And here, the domain, where's the domain? The domain of your inverse function is the range, the y of your original function. And the range of your inverse function is the domain or the x's of your original function. Now, how to write the inverse? So a while ago, you simply write the inverse of this, g of -1 of x. Is it important to write the -1? Yes, because it is an indicator that it's already the inverse of the function. So we have a1, so next, b2, c3, d4, and e5. How about for the next one? You simply exchange them. You can write it again as x and y, but it's simply writing this all for the x and writing this all for the y. Now, what if it's an equation? How will we write the inverse function? Take note of these steps. The first step is you change your f of x to y. Then, after changing it to y, after changing it to y, you need to interchange your x and y. So the x becomes y and the y becomes x. And the moment you interchange them, you need to change y to the power of -1. It means that we already made an inverse or the interchanging. Then the last is we write the solution from y to the -1 to f to the -1 of x, and be sure to solve it in terms of x. It means that we only have y to the -1 on the other side. Let's start, okay? I'll teach you first the logical method before I'll teach you my technique. Now, the first step, you change f of x to y, then copy 1 minus 2x. Then, step 2, we interchange x and y. So this is y, we make it x. While the x, we make it y. But since we interchange them, we write it y to the -1. Then we solve for y in terms of x. It means that we transfer y to the other side and we transfer x to the other side. Divide both by 2. So y to the -1 is equal to 1 minus x over 2. The last, you change y to the -1 to f to the -1 of x. Then copy. So this is now the inverse function of f of x equals 1 minus 2x. Any questions? We can go to the next problem. Let me change my ink color first. Okay, now for the second problem, again, you change f of x to y. Then what's next? We interchange x and y. So y becomes x and x becomes y. It's the -1, but there's a square, do not forget. Then we will solve it in terms of y, right? So divide all by 3. What I say is we need to solve for the value of y. So we have y to the -1 squared equals x over 3. And to cancel the squared, we need to find the square root of both sides. So we have y to the -1 equals square root of x over 3. It's a square root, so it's plus and minus, positive and negative. Then lastly, we change y to the -1 to f to the -1 of x equals plus and minus square root of x plus 3. Any questions?
None, ma'am.
Thank you. Let me teach you my technique. Okay. My technique is not found in the books. Actually, I'm teaching you my technique based on my observation as I keep on solving. So here's my technique actually. If it's a constant term, it remains as a constant term. So still 1. But if the other is negative, it becomes plus. If there's a variable, it stays with it. But the numerical coefficient of the variable becomes the denominator. That's it. Let me, like this one. Let's have another one, okay? Let me teach you the technique for this. Without solving much, here, the constant remains constant, but it's plus, so it's minus here. The variable will remain, and this one, the numerical coefficient of the variable becomes the denominator. How about for this one? I simply do it this way. The denominator becomes the coefficient of the variable. So we have 3x, it's minus, so you have plus 10. That's it. Actually, even if you solve it, the answer will still be the same. That's after the negative 1 of x equals 3x plus 10. How about if there's a square root, a squared? So here, oops, there. That's after the negative 1 of x. I told you a while ago that the coefficient becomes a denominator. So what's left is x. But this is squared, right? And the inverse of squared is a square root. So square root. Then it's a square root, so you need to have plus and minus. Any questions? No other questions? Then we can go to the domain and range. Now, how do we solve for the domain and range of the inverse function? Now, remember that the domain is the set of all the x's, while the range is the set of all your y's. Let me teach you the technique immediately. For the domain of the function, you have after the negative 1 of x, you check in the denominator. The denominator should never be equal to 0. Now, ma'am, what if it's a square root? If it's a square root, under the square root sign, remember that this one inside should never have a negative answer, or else it becomes undefined. So the answer to this must be greater than, the one inside must be greater than or equal to 0. The smallest is a 0. So the one inside, it must be greater than or equal to 0. That is for the domain. Now, how do I solve for the range? I suggest that remember, in your f of x, in your original one, the set of all your domains becomes the range in the inverse function. So for your range, you go back to your original answer, to your original function. If it's a fraction, then the same. Denominator should never be equal to 0. And this one, if it's under a radical sign, it must be greater than or equal to 0. If there are no restrictions, then good to go. It means all real numbers. Let us have some examples. Ready? Now, I suggest you start with the range. It's easier. There's no denominator, there's no square root, so free to go. It means that the range is from negative infinity to positive infinity. How do I state it? It means all real numbers. Next, how about for the domain? if I'll have my inverse function of this, that's why I taught you the technique. That's 1 plus x over 2. Now, there's no variable in the denominator, so it's good to go. It means our domain will be all real numbers. Let's go to the second one. The range here. If you check with this one, remember when a number is raised to an even exponent, the answer is always positive, right? So your x can take any numbers. Therefore, the range of that is, the lowest is 0, 0 squared, and the lowest is 0. But if you'll try the next one, if it's negative, the next answer will be 3. So we say our range is the set of all real numbers from 0 to positive infinity. Or we say our range is y such that y is greater than or equal to 0. Or in the interval notation, it starts from 0 to positive infinity. How about for our domain? We need to write the inverse of the function. And it is x over 3. Remember that we are under the radical sign. So this one must be greater than or equal to 0 for it to be a real number. So if you'll solve that one, cross multiply, x should be greater than or equal to 3 times 0. So x should be greater than or equal to 0. So we say that our x is a set of all numbers greater than 0. That's it. Any other questions? How about the next one? Okay. In the next one, let's start with the range. In the range, there's no denominator, so all real numbers. How about for the other one, the range? There's no variable in the denominator, so we say all real numbers. It means that any number can be the value for y. How about for our domain? Let's have the inverse. That's x minus 5 over 2. There's no variable in the denominator, so we say all real numbers. How about for the other one? It will become 3x plus 10. No denominator, no squares, so we say all real numbers. Any questions?